CYPE3D is a powerful program that can carry out structural calculations in 3 dimensions for bars made up of steel, timber, aluminum, concrete, and even finite element shells. It has been developed to offer greater assistance for the user in the design of these material-based structures. CYPE3D analyzes the elements from these structures against selected building codes and produces a detailed check. This program has been adapted to the technical building code from countries around the world, and can also perform fire resistance and earthquake analysis. To properly showcase this program, I will be using pre-made examples of a water tank and of a warehouse that was created using the functions found in the above headers. In the Project tab, the general data contains options which allows users to define the parameters of the project, including the specific types of materials for each section and its appropriate building codes, where there's a variety to choose from. Here, the user can also define the load cases that will be acting on the structure, such as wind, snow, and earthquake loads. In the Bar tab, the user is able to create new beams and columns with a wide selection of materials, such as rolled steel beams, reinforced steel beams, cold-formed beams, timber sections, and so on. Other features in the Bar tab include adding pin ends between the joints and any buckling or lateral torsional buckling should there be any acting on the bars. In the Node tab, users are able to define internal and external fixity. For external fixities, the user is able to choose the support type they wish to use, such as a rolled, pinned, or fixed support. And in the Planes tab, users are able to manage the different viewing planes of the project, as well as adding levels and grids. One of CYPE3D's key feature is that it can carry out an automatic analysis and design of joints. I will be using the warehouse example to better showcase the functionality of this tool. In this example, the program can generate automatically all the joints throughout the entire structure. Each joint is designed accordingly with the most efficient and suitable properties, such as its sizing, dimensions, placements, and materials. It will also include stiffeners into the section where it is necessary. If the user wishes to modify some aspect of these connections, they can do so by selecting the joint they wish to change and then clicking on the design option where they can choose from the type of connection they wish to use. To further modify the properties of these connections, the user can click on the Edit button next to the desired beam or column they wish to change. For welded connections, the user has the option to change the weld's throat thickness, design type, length, and how it can be executed, either at the workshop or on site. For bolted connections, the user has the option to choose whether the bolts are pre-stressed or not, along with all other design parameters such as the series code, the steel class, the available diameters, and the friction surface class. Additionally, CYPE3D is capable of designing and analyzing pre-qualified connections for special and intermediate steel moment frames. These special types of joints are used for seismic applications for stronger and sturdier connections. After the joint design is completed, the program is able to provide the construction detailing for each joint, where it includes a summarization of the properties in the detailed technical drawing. The program also provides a check report for each element against the according building code that was defined at the beginning of the project. The connections that meet the requirements will have a green check next to the code, and for those that don't, the check will show what needs to be changed. Another one of CYPE3D's key functions is that it enables users to define shells within their projects. Shells are two-dimensional elements that has its parameters defined by a polygon with a constant thickness. Shells are introduced in the global stiffness matrix of the structure using a three-dimensional finite element model, which is composed of a quadratic triangular flat shell. In this example, the entire sphere of the water tank was created using shells. As you can see, CYPE3D is capable of defining the following properties for each shell: the thickness and subgrade modulus, the position of the shells, the discretization, the direction of the axis, the materials, the integration strips, and the internal and external fixities. In order to access the shells function, the user must have the appropriate permits for CYPE3D. Once the user is finished with the design of the structure, CYPE3D is then able to analyze the structure and generate a detailed report on the ultimate limit state checks for steel and aluminum sections. These checks have a level of detail that allow users to use it as a guide in order to optimize the design. It not only displays the equations used to calculate the check, but also the variables and explanation of what these represent. The program's database has a long list of code checks to run through. If the section meets the building code standard, then a green check mark will appear next to the code. If it fails, then the program will show which variables do not meet the requirements. This feature is a powerful tool offered by CYPE 3D because it allows users to have a clear mathematical understanding of the calculations behind the project. A complete listing of the checks can be summarized into one file to be printed and exported as a PDF, docs, or HTML. Other features from the analysis include the forced and deformed shape diagrams that can be consulted graphically or analytically on the screen. That concludes the general overview of CYPE 3D. Thank you for watching.